Hello. So today I will be solving one LeetCode algorithm question about the sliding window. Okay, so let's get started. So this is my today's question. So given an array of positive integers nums and a positive integer target, returns the minimum ranks of the subarray whose sum is greater than or equal to target. If there is no such subarray, return 0 instead. Okay, so in this question, I will be giving an array of positive integer nums and positive integer target, and I will be returning the minimum ranks of the subarray whose sum is greater than or equal to the target. Okay. So I will be defining the interface first. So in this question, I will be returning. Yeah. So returns the minimum ranks of subarray whose sum is greater than or equal to target. I see. If there's no such subarray, return 0 instead. Okay. So let me think of before working on the implementation, obviously, I will be doing the validation, confirmation of the data input. So nums is the array of positive integers. And length can be 0. Okay. And also for target, this should be, okay, I will check the constraint of this question. Target is more than 1 and nums ranks is more than 1. Okay. So, okay. Whose sum is greater than or equal to target. Okay, see, yeah. So I will think with some examples. So for example, if nums is say like this, and if the target is say 6, in this case, I will be returning the minimum ranks of subarray whose sum is 6 or greater. Yeah. Okay, so let me think with this example. So if I fix the right end, so this one has the sum of 3, so this is okay. And no, this isn't okay because, yeah, I'm looking for the subarray whose sum is greater than or equal to 6, so this is okay. And if I move the right pointer to 5, this range 3 and 5 is okay because now sum is 8, so this is okay. And here I cannot shrink this. I can move 3, left pointer to 5, because currently the sum is 8, and if I shrink the left pointer, it will be reduced to 5, which is less than 6. So I still cannot shrink this range. And when I think of this, so when I have 1 included in the subarray, now the sum is 9, which is okay. And oh, because I'm looking for the minimum length, I'd like to shrink the window as much as possible. So if I can move the left pointer, if possible, I'd like to move it. However, here, current sum is 9. And if I shrink this left index, left pointer, and if the window has only 5 and 1, the sum is 6, it's okay. So what I can say from here is that I can shrink, and now the sum is becomes 6, it's okay. Yeah. Then when I get 6, I will expand the right, I will move the right pointer, and I will, broaden the sliding window, and now I have the sum is 12, which is okay. And obviously I can shrink it. So shrinking like this is fine. So now the sum is 7, it's okay. And okay, then also when I shrink this again, it's okay. Now the length becomes 1, it's okay. Yeah, so let me finish with this. This is enough. Okay, so that being said, so when I take a look at this, so this is rank 2, rank 18, the rank is 2, in rank 19, rank is 3, in rank 20, the rank is 2, then rank 3, rank 2, rank 1. So I will return 1, which is the smallest ranks of the window, whose sum is now 6. Yeah. So yeah, probably, yeah. Obviously I use the sliding window whose sum in the window, subarray is 6 or greater. Yeah, target or greater. So I want to keep the sum of the window to be equal or more than target. And every time I move the right pointer, then, I will be shrinking the left pointer. So that's a basic algorithm what I can do here. So simply saying for each right pointer, move left till okay, until the or I should say, as long as the shrink window sum is target or more. Yeah. Then after shrinking it, I will be, update the mini ranks, which is shared globally across the 4 of steps. And then I will be returning mini ranks. So this is the basic algorithm I can use. So, I've written the pseudocode. Yeah. So with this approach, the time complexity should be O(n) and space should be O(1). So let me tell you why. So for time complexity, I will be moving the right pointer and left pointer. And the thing is that the right pointer never goes back and left pointer also never goes back. So yeah, that's why this time complexity isn't n squared. So since the right pointer never goes back, I just have to think that, so, okay, the number of steps of the iteration is exactly 2 times n, because I have to move left pointer or right pointer in each step, and the end of the iteration is, in the worst case, left and right pointers reach the tail of the array. So in total, they move 2 times n. So, and in each iteration step, only, either of the pointer is moved by 1 step. So in the worst case, it takes 2 times n. So the time complexity is O of n. And for space complexity, I don't need any extra data structure. So yeah, it will be constant. Okay, so that being said, I will doing the implementation. Okay, but before that, let me write the test. So okay, one of the edge case I have to think of is, so I will think from the edge case. So there is no such subarray, which means the condition. So in this case, say I get 3 and 4 and 5, and if I guess the target is 2, there isn't any subarray, so I should return 0. And also I will be thinking of one happy path. So it should be like this. So let's see. Minimum. Okay. Maybe I can say like 7. Yeah. Or maybe. So in this case, the subarray whose sum is 6 or larger should be 4 and 2 in index 1 to 2. So in this case, it should be returning 2. Okay, so these are test cases. So let me do the implementation. So because I removed the left pointer, okay. I will be beginning from mini runs. Yeah. And so for each right, and as I have to keep track of the sum of the subarray. Okay. So every time I move the right pointer, it means that the window is within. So I have to add current right number to the current sum. Yeah. Then from here, I will be moving the left pointer as much as possible. However, if the current sum here isn't enough, I cannot move any. I cannot move left pointer. So in this case, I will continue. Okay. And from here, I will move the left pointer. So the condition that I can move the left pointer is that even if I move the left pointer, after moving the left pointer, sum of the subarray has to be equal or more than target. And while it would be met, I can move the left pointer. And I'd like to move the left pointer as much as possible. So I will use I used the while loop here. Okay. Then here, it is guaranteed that the current sum of okay, and now here in line 50, it is guaranteed that the current sum is more than or equal to target. So yeah, I will update the mini ranks with this. Mini ranks. Oh, okay. So I will get the current ranks as like this. Then I will update the mini ranks. Okay. So after that, after finishing the iteration, I will be returning many ranks. However, if there isn't any subarray which meets the condition, many ranks is still float infinity. Infinity. And in that case, as the program statement says, I have to return 0. So if the current mini rank is float infinity, I will return 0. And otherwise, I will be returning mini ranks. Okay, so that's the implementation. So let me quickly check this code. So yeah, I will be testing this with, I will be walking through this code with the hobby case. So in this case, nums is 342 and target is 6. So mini ranks is started with infinity, and current sum begins with 0, and rest begins with 0. Okay, and I will be moving the right pointer from 0 to 2, and I will be doing it from 0. So here, when right is 0, current sum is incremented by 3, so this becomes 3. Then in line 44, current sum 3 is less than target, so I will be continuing here. So in line 42, now the right is 1. So in line 43, current sum is incremented by 4, so this becomes 7. And in line 44, current sum 6 is not smaller than target 6. So I will go to line 47. And here, current sum, because left is 0, nums left is now 3. So current sum minus nums left is 7 minus 3 is 4. So yeah, I will be checking if 6 is less than 4, and this isn't true. So I don't go into the while loop, and I go to line 51, and now current ranks is, so 2 minus 0 plus 1 is right is 2, left is 1. No, right is not 1. So now this is 2. So mini ranks is updated with 2. So now it is 2. Okay. And I will go back to line 42. And now right is 2. So current sum is increment by 2, and it becomes 9. And then in line 44, current sum 9 isn't smaller than target 6. So I will go to line 47. And here, current sum is 9. And nums left is 3. Oh, okay. So current sum minus nums left is now more than or equal to target. So in line 48, current sum is removed, decremented by 3. So this becomes now 6. And in line 49, left is moved, shifted by 1 index, and now it becomes 1. And now in line 47, current sum is 6, so I can't move it anymore. So in line 40, I go to line 51. And now current ranks is 2 minus 1 plus 1 is 2. Yeah. So actually mini ranks is, yeah, the same. It's still 2. And okay, now in line 54, because mini ranks isn't for infinity, now it is 2. I will be returning mini ranks 2. Okay, so yeah, I confirmed that the test case line 60 passed. Okay, so I'm pretty sure that this code works. So yeah, probably that's the end of my coding practice today. Thank you. Oh, and sorry, but I've just run the code and I find that so the line 58 failed. So 3, 4, 5, 2. Let me quickly check it. So sorry, mini ranks num sum is greater than or equal to target. Oh, sorry. So let me think with like 15. Okay, so the test case was wrong. So I wanted to confirm the case when the total sum of the array is smaller than the target. In that case, even if the subarray is the whole array, whole given array, the sum doesn't exceed or equal to 15, target. So in this case, the mini rank subarray function should return 0. So yeah, that's what I want to check. Okay, good. So yeah, I confirmed that the test, my test passed. So yeah, I will finish my practice today. Thank you.